Hi guys, today we're going to learn about ions. And so ions all relate to this thing called the octet rule. Oct is a clue. As soon as you see that, you should think like an octopus. It has something to do with the number 8. So the octet rule is atoms are most stable when they have 8 valence electrons. So this is every atom's dream. My dream is to get $1 million. I hope that it happens. An atom's dream is to just have 8 valence electrons. That's what they want the most in the world. So if I think about it, you know about valence electrons from our last page. This is based on the group number. So you know that the noble gases over in group 18, they already have their full valence electrons. They have that full octet. So these are the happiest elements in the world. They have their 8 valence electrons. They're really, really good. If I think about their neighbors, the halogens, group 17, they have 7 valence electrons. So they're really, really close. They just need to gain one more electron to get their octet. Group 16 has 6 valence electrons. What they would need is they need to steal 2 electrons, and then 6 plus 2, that would give them their 8 valence electrons. If I keep going, group 15, they have 5 valence electrons, so they need to gain 3 to get their full octet. Okay? Group 14 is weird. We're going to skip that for a minute. Group 13 has 3 valence electrons. Now, there's 2 options here. If we have 3, we could add 5 valence electrons, but that's a lot of work. It's much easier to lose 3. If I give those 3 valence electrons away, then the core electrons inside will be the full octet. So what's easier to do, add 5 or lose 3? It's easier to lose 3, so that's what's going to happen. Group 13 is actually going to lose 3 electrons, and then they will have their full octet hidden underneath in their core electrons. We're going to skip the transition metals again, go over to group 2. They already have 2 valence electrons. Again, they have the option. They could 2 plus 6 electrons, so they could add 6 electrons, or they could lose 2. Those are their options to get the full octet. It is much easier to lose 2 electrons than go out and add 6 more. So that's what's going to happen to the atoms in that group. Same thing in group 1. They have 1 valence electron, and they're just going to lose that one. That's easier than gaining 7. That's how they're going to get their full octet. So this is what the atoms are going to do so that they can obey that octet rule. In all of these 3, in group 13, group 2, and group 1, their core electrons then become the valence shell, and that's where they get their octet from. Okay? So this has to do with something called oxidation state. This is the charge of an ion needed to follow the octet rule. Octet rule again means 8, and the oxidation state has 2 parts. There has to be a charge, and there has to be a number. So that charge means, are they going to add or are they going to lose electrons? And the number is how many. Okay? So if I say a plus 3, that means they're going to add or gain 3 electrons. If I said a minus 2, then they're going to lose 2 electrons. That's what oxidation state means. And so an ion is when that charged particle changes its number of electrons. Okay? So 2 options here. You can have a cation, where it has a positive charge because it has lost electrons. So a trick here, if you're a cat person and cats make you happy, then you can remember cat means positive. Another option is the T in cation looks like a plus sign, so you can remember that that one is the positive one. And that happens because it loses electrons. I know that seems backwards because it's an adding, but it actually loses electrons. Lots and lots of these things are going to be opposite. So positive loses electrons. If it's not positive, then it's negative, and that is called an anion. This is where it has a negative charge by gaining electrons. So you can remember this one is a negative. Well, that looks terrible. ion. So an anion is a negative ion. So it's negative because it has gained electrons. Again, it's very backwards, which makes it really tricky. Okay? So, oxidation is the process of losing electrons, like we have here. And reduction is gaining electrons. Again, it's very backwards. Reduce means gain. So there's a little trick to help you remember that. You have a choice here. You can remember Leo the lion says grr. So L-E-O, his name, stands for losing electrons oxidation. And when he roars and says grr, it's gaining electrons reduction. So there's an option to help you remember that. If you don't like that one, you can do oil rig. Okay, so OIL stands for oxidation is loss, reduction is gain, RIG. So choose one of these and write it down in your notes, whichever one you like better, and will help you remember them. So when we have these ions, metals are going to become positive ions and nonmetals will become negative ions. So remember that positive is cation, so metals become cations and nonmetals make negative or anions. A good way to remember that is nonmetal and negative both start with N. Group 14 that we skipped is a little bit strange because it has metals and nonmetals. So the metals that are in group 14 will become positive and the nonmetals will become negative. So that's the only group that's a little bit strange and doesn't have just one or the other. So that gives you the charge, the positive or the negative, and then the number comes from the group number. So again, just like we skipped the transition metals, there's no pattern for valence electrons and there's also no pattern for oxidation number. But because they're metals, they're still going to lose, but there's not a perfect pattern for the number. So here's the pattern you need to get in your head. Everything in group 1 will become a +1 ion. Group 2 will become +2. Remember, we skipped the transition metals. Group 13 will become +3. Then we get to the weird group 14, so some of those are plus and some of those are minus, and that's 4. Okay? And then we switch it up. Now we get into the non-metal territory. So it becomes a -3, has to be negative because it's a non-metal, -2, -1, and the noble gases over here, they're happy. They have their full octet, so they are 0. So this is the pattern that you need to get in your head. +1, +2, +3, +/-4, -3, -2, -1, 0. That's going to help you predict the ions and the oxidation states for those elements. So let's talk about what this means. Okay, if I think about an atom of sulfur, okay, sulfur, the atomic number for proton or for sulfur is 16, so it has 16 protons. For neutrons, remember we do mass minus protons, so it has 16. But it's possible to change the electron number. Okay? In an atom, the electrons will still be the same. But in our ion, it's going to be a little bit different. So if I think about where sulfur is right here. Its oxidation state based on its group is a -2. Still has the same number of protons, same number of neutrons. But the electrons have changed, and that's where that -2 charge came from. I started with 16 electrons, okay? It's a -2 charge. So if I think back, a -2 charge is an anion. It is a negative ion, and that means that it gained electrons. So that means the 16 that I started with, we actually added 2, and now it has 18 electrons. Because we gained electrons, if you think about either oil rig or Leo the lion, that is reduction that happened. When we gain electrons, it is reduction. Alright, that's a little strange. Let's do one more. So let's think about sodium. The atomic number for sodium is 11, so it has 11 protons. Neutrons, we do mass minus protons, 12. The electrons are equal here because it's an atom. So notice wherever there's an atom, protons and electrons are equal. It's in the ion that the electrons will change. So let's find sodium on the periodic table. It's here. Okay. That means that it has an oxidation state of +1. That leaves the protons and it leaves the neutrons the same. The difference is those 11 electrons that we started with have now changed. A +1 means that we have a cation because it's a positive charge. That means that we have lost electrons. So I'm -1, and this ion actually has 10 electrons. So in this example, we lost electrons. Thinking about either oil rig or Leo says GER, losing electrons is called oxidation. Alright, this is something that takes lots of practice, so go ahead and work on your next page and come and let me know if you have any questions.